Okay, so first of all, there's a homework problem they want me to work out because they couldn't cover it in class, which sort of means it's really important. It was something like, this is number 27 on your homework.
We did this class.
You guys did? It was you guys did this? Did you guys do it in your first class or some other? Are there any students who didn't do this in class? Yeah. I'll quickly do it, but because they asked me to do it here, which means there's going to be a problem like it on the exam. So we multiply by the conjugate. So right now I just multiplied by the conjugate and I'm simplifying it. The important part is that this changes to absolute value, which I can rewrite. And they want you to write this negative x since x approaches negative infinity. They want to see that on the exam. Like, since you need to show that, yeah. And then you can sort of pretend it's 12x or something. You can show that these two factors go to 0, and the answer is -5/12. You guys all good? You did several problems like this, but the important part, once again, is to know that that changes to -x. We all good? This is -x. This here changes to square root of 36.
No, I'm talking about what you have highlighted in yellow. It says -x at x.
Oh, yeah. So it'd be like that. So it'd be plus 6x. We'll do another problem like this, so don't worry about it that much. But it means something like this is going to be on the exam. Are we good? Or okay. Going on to the first problem on here. Let me actually do something different. This way I don't have to write everything. Okay, so the first part is simple. We take the derivative of each section. So we have, does anyone want to say it? What would I put at this part? Negative 2x. The derivative of the second part of the function is, does anyone want to say it? 2x what? Minus 8. Now here's something that's a bit tricky, and they will look for this, is what we write as the domain. It's between -1 and 2, but not equal to 2. And then at the lower part, it's less than, but not equal to. That's very important. They'll really look for that. Okay, do you guys all understand why it is like that? Because it's the idea where the derivative, as that's approaching from, say, the right-hand side, that's different than the limit approaching from, say, the positive side. Yeah.
For the inference, if you have to leave the so less than or equal to sign, you have to leave the equal to sign off. That's how you check.
In your work, you just leave it off whenever you show the domain. And then you do show it later on that it should be equal, but it's the idea where right hand as the derivative from the right hand side is not equal to the limit approaching from the right side. Sure, they end up equal when we do the math, but those are two different concepts, and you can't just blatantly say that it's the same thing. Okay? So, I mean, it's nothing big, but you just need to show that. And then the second derivatives are -2 and 2. And then once again, we don't make it equal to 2. Okay? Also, it could be if, like, there's a cusp or a corner or something, and a derivative doesn't exist, so we can't show that. We can't assume that it exists there. Are we good with that? So first things first, we need to prove that the function is continuous. What's the first step? That's the second step. The first step is just showing what the value is of the function. So we just do f of 2, that's equal to 4 minus 2 squared, that's 0. The second part is limit as x approaches 2 from the minus side, f of x, which is 2 from the minus side again, and then we use 4 minus x squared as our function at that point. That's equal to 0, and from now the right side, 2 from the positive side, we use x squared minus 8x plus 12. That's once again equal to 0. Therefore, the limit as x approaches 2 of f of x equals to 0. And then finally, we can say the limit as x approaches 2 of f of x is equal to f is equal to 0, which is equal to f of 2. Therefore, f of x is continuous at x equals 2. All three are important, and you need to prove all three in order to move on. No, but they want you to. And the third statement isn't really a step, it's just showing what you found out, but you do need to state it. Looking at the derivatives now, at 2. That's the limit as x approaches 2 from the minus side of negative 2x, that's negative 4. From the right-hand side, 2 from the positive side, we use 2x minus 8, that's negative 4 also. Therefore, the derivative of 2 is negative 4. Are you guys all good with that? Just testing a point after you know what to use. And yeah, the other thing happens is when I use OneNote, I can write really fast rather than writing on the board, which takes more time. So if ever you guys need me to stop to let you guys write, just let me know. So we're gonna move on now. So the second derivative at 2. Two from the minus side, that's just negative 2. 2 from the positive side, that's just 2. Therefore, at 2, the second derivative is undefined. Any questions so far? And they'll ask you what's, the derivative from coming from the left, coming from the right. So you shouldn't get worried about that. Once you see it, you'll immediately know what to do, or you should. Are you guys good with that? All right, moving on. So finding all the candidates for max and min. What is the first step? Where the derivative are equal to 0. And the derivative was negative 2x. They're equal to 0. Therefore, x is equal to 0, y is equal to 4. And the second part was 2x minus 8. We need to find where that equals to 0. That's when x is equal to 4 and y is equal to a negative 4. What's the second part? Undefined. Since in this we don't have any denominators or anything like that, there are no places where it's undefined. So we can actually just say, therefore, no possibilities. And you should state something like no possibilities, and because they want to see that you know what you're supposed to do. So stating it's like undefined and there's none is important. And what's the third step? Endpoints. So we had x is equal to negative 1. That means y is equal to a 3. And x is equal to a 5. That means y is equal to a negative 3. Or negative 1 for the first one. And that's pretty simple. That's just knowing the endpoints and finding y values for them. Yes.
For the first part, where do you get y equals 4?
This. We plug 0 back into the original function. all the way up here. We get the value from these because we're testing the derivative when that's equal to 0, but the by value in the graph is the actual function, which is all the way back up there. So yeah, that's a good question. Are you guys good with this? You did that last week or so. So now we have to justify them, and they ask use second derivative test where possible. So that means if you use the first derivative test, you lose all points. So you need to use the second derivative test. So the first part, the second derivative test is testing for concavity. So f double prime of 0, because that's the x value that we got, is equal to a -2, which is less than 0. What does that mean? Max or min? Max. You don't need to draw the sign, sure. If you want, yeah. Like, you should get familiar with this and understanding it like this, because there won't be much time to do it for everything, like drawing a sign chart for everything. But if you can, if you want to. So that means we have a local max at 0, 4. And testing it at 4, that's equal to 2, which is greater than 0. So do we have a max or a min? Max or a min, guys? Min. Local min at 4, 4, -4. So this one's like that, and this one's like that. That's a min. That's what do I do for the second part? We don't have any candidates, so we can just put a line through that. Looking at the third part, if I take the second derivative test of -1 from the positive side, what do I get? Anyone? Exactly. I shouldn't be doing the second derivative test. Should be the first derivative test. So we approach -1 from the right side because it's a left endpoint. That's equal to a -2 times a -1 from the positive side, which is greater than 0, since it's negative times negative. Is that a max or a min? You can know with the left and the right. The best thing to always do, in my mind, is I always draw it out. So if the slope is greater than 0, that means it's going up. And that's a local min. So whenever I had Calc 1, I used to always draw the sides out. It's just easier to see. From 5 from the minus side. So looking at 5 from the minus side, that's a +2 times 5, which is greater than 0. So if we were to draw that out, is that a max or a min? Max. Yeah. 1 sec. Okay. Why would I not plug that in to the original function? Or did you say 2x minus 8? Let's see what they do. Did it? You should actually plug it in, and they made a mistake on the answer key. Yeah. So minus 8. Yeah. Most of the time, the first part is gonna matter, and the plus or minus number isn't gonna change anything. So just by looking at the problem, we could tell it's greater than 0 or less than 0, instead of actually calculating the exact value. It just saves time, but they should actually have shown the minus 8 there. That's right. Do you guys understand that? Good job on. Do you guys need me to wear the microphone or something? No? Okay. And anyone who came late, make sure you guys come down and at the end check in. Yep. So we are good with that. So now finding the points for inflection, finding all the inflection points. What do we look at? Where the second derivative test equals what? 0. That's the first part. And do we have any points? No. Terrible. What's the second part? Is undefined. And we actually do have a possibility. That's when x is equal to a 2. And y would be equal to 0 or 2. And we know that that's a possibility because we have two different values when we look at 2. Okay? That's how we know x equals a 2. We need to test that. That's also why we don't have an equal sign there. Because if we had a value where the second derivative of 2 was equal to something, it wouldn't be undefined. So to justify that, for the first part, we don't need to justify anything since we don't have anything. The second part, if we approach 2 from the minus side, we get negative 2, which is less than 0. Is that concave up or down? Concave down. And if we approach 2 from the positive side, that's greater than 0. Is that up or down? Up. So the concavity changes. What's the last thing that I need to show? A unique tangent or unique slope. And we can do that by looking at the derivative, which gives us the slope. That's equal to a negative 4. That's a unique tangent. Therefore, inflection point at 2, 0. And you need to clearly state all of that. Yeah. When we graph it? Or? If you want to do it for yourself, yeah.
So I have to write that. If I were to sign for that, would like to find it.
You should still write it out. 'Cause, yeah. When you don't have a value, you have like infinity or undefined or something. Unique tangent means you just have a number for the slope. Are you guys good with that? Yeah.
Whenever you have plus or minus infinity,
That would,
because you have a, dot, right?
that's a corner or a cusp or something. That's not an inflection point, if that's what you're thinking of. When you have something like that. Yeah. Concavity is still positive. That's still positive. To graphing it, that's just taking all of the points that you found and plugging them in. So at -1, we had a 3. At 0, we were 4. At 2, it went downhill. At 4, it was a -4. And at 5, it was a -3 or something. Yeah. And then it's connect the dots. I'll see. It's important to show your coordinate points when you label them. They'll look for that. Pretty sure. Yeah. Not on the graph. That's all you need, but you need to make sure that you show everything. Are you guys good with that? You did a lot of problems like this in class too. So. Moving on. Okay. So they ask us to take the derivative, which is just 1 minus 2 over 3 times x minus 1 to the 1/3. Do you guys want me to show how I got that, or are you guys good? Good? Okay. The second derivative is just, since the derivative of the 1 is equal to 0, it's taking the derivative of this, we can rewrite that as, if that helps you guys, so that you don't have to do the quotient rule. And we get 2/9 times x minus 1 to the 4/3. No, it's actually positive. Should it be negative?
No, you got that minus there, multiplied by negative.
Yeah. Yeah, don't forget this negative sign here. So make sure you guys do that correctly and not lose easy points. So we need to find all the values for the cusps. That is testing the limit as x approaches 1 from the minus side and the positive side. And the way we know that is we have a denominator where it could equal to an undefined. If we had 1 for x, it'd be undefined. Yeah.
So are the candidates discussed on your double prime to define or also for up double prime zero? Is it like if you did the leftovers and the second points, like, if you have candidates for the second point to work, then you test it.
So that's a custom, so the following concatenates is the same on both sides.
I think it's when f prime. Yeah, f prime equals undefined. Is that what you said?
Well, if custom where the concatenate is the same on both sides, it means that it won't ever be zero because that's the cap.
Yeah. We're f prime. Tested we're f prime. The way they it might make sense when I should do this, but f prime of x, that's equal to limit as x approaches. Because you're looking, so cusp can be like this. That's when the slope is approaching infinity and then sort of minus infinity from the other side. So you can look at the slopes to find that. So we have 1 minus 2 over 3 times x minus 1 to the 1/3. That's equal to infinity. And we can show that because we have 1 minus 2 over 0 coming from the negative side. But it's still. So this would be a negative number. So negative times negative positive. Are you guys good with that? If I had, instead of the 1/3 as the exponent, if that was a 2/3, that means even though the 0 is coming from the negative side, this would be squared. So then you'd have a negative infinity. Keep that in mind. They might have something like that on the test. So you need to make sure by looking at that exponent as well, rather than just saying, yeah, it's coming from the negative, it should be negative. They could trick you. So now coming at 1 from the positive side of f prime of x, that's 1 minus 2 over 0 from positive. And we also looked at the double prime of 2 over 9 times x minus 1 to the 4/3. That's a positive value always, because exponent is 4/3. So the double prime is always 0 for when x cannot, all values for x does not equal 1. Therefore, concavity doesn't change. Therefore, 1 comma 1, we have a cusp. So 2 things to remember. The second part is showing the concavity. It's greater than 0, so it's concave what? Up. Looking at the slopes coming from the left side, going up, coming from the right side, going down. They're both concave up. The concavity doesn't change, that's why we have a cusp. And both of those are important. Any questions on that? No questions? You guys all write it? Or anyone still writing? No? Oh. Or you guys can look at it for a few more seconds. Okay. This problem is like the problem that I did with the homework. You just need to remember to multiply by the conjugate. So we're approaching negative infinity. On the top we have x squared plus x minus x squared minus x all over square root of x squared plus x squared minus x. We can simplify that further. We're approaching minus infinity of 2x all over. We can take out the square root of x squared from both of them, and we'd be left with square root of 1 plus 1 over x plus square root of 1 minus 1 over x. This tells us it's an absolute value. Do you guys have all that copied down? No. Okay. So that's equal to the limit as x approaches negative infinity of x over negative x times 2 over the entire denominator. That's equal to negative 1 times 2 over square root of 1 plus 0 plus square root of 1 minus 0. That's negative 2 over 2. So the answer is negative 1. Just a whole bunch of simplification. Now,
In the bracket, it's 1 plus 1 over x minus.
this should be a plus.
Okay.
Yeah.
So if we were approaching positive infinity with the absolute value x positive x.
Yeah. Yeah.
I just wrote it differently. I'm not sure I got the answer. Instead of moving the x squared to x squared out, I simply divided the numerator and the denominator by 1 over x. I got rid of my x over the top, and then on the bottom, the x put 1 over x becomes 1 over x squared. You see something radical? And I ended up getting 1. I'm not sure why that's
Did you still have a 2 on the top? And you got 1 as a denominator?
So you use the denominator because this is square root of 1 plus the square root of 1.
Do you forget to like add these two parts, or do you just multiply them?
No, I just took the limit of all that, and then, so basically, I never pulled out the square root, or the square root of x.
Yeah.
I just divided all of that, and multiplied all that, times 1 over x, which then the x goes under the radical, it becomes x squared. So then I guess the first term, you can just 1 plus 1 over x.
The second term would still be 1 though. So
But the thing is, I don't have the negative out on the outside then. I don't have any negative, so it just ends up being equal to 2 instead of negative.
then somehow you should, I'll look at it, but it should still work out. So do you guys understand how this worked out though? Okay, before we get into asymptotes. Yay. That's one of them. I think I showed you guys this one. Yeah. That's from differential equations. I think I showed you guys. That one's pretty good. That's how it feels after your summer semester. That doesn't happen much. These are what we posted over the summer when everyone, almost everyone had statics, which is like about building bridges and stuff. That's on Sunday. I guess it's like the principals, or the professors. On that note, Alrighty. So the first thing you need to do is you need to divide those two terms. Okay? So we have x, and then we get x squared plus 2x. We subtract them, we get minus 3x minus 2. A lot of students just forgot to do this or didn't know they had to, so they missed a lot of points. So we do this so that we can rewrite f of x so that it has a dominant term.
What's the definition of dominant term?
It's like when you're basically when you're approaching plus or minus infinity, which part of the function rules how your graph looks like. So I mean that's as technical as that's exactly what you need to do basically. So we know it's x minus 3 since 4 over x plus 2 approaches 0 as x goes to plus or minus infinity. You never use that term besides this unit, sort of. So you never use the term dominant after this unit, or
Okay, good.
I don't remember using it. But. Find all dominant terms when x approaches -2. Now that's when that little part of the fraction comes into play. Since the denominator is x plus 2, you can say since 4 over x plus 2 approaches plus or minus infinity as x approaches -2. And you need to write out all of that, just saying, because they ask you to justify it.
You don't have to write like you don't have to write the limit.
No. And those two are worth 1 point, so if you don't justify it, you lose everything. That whole section, like part B, is worth 1 point. So if you just show which part is the dominant term, you don't get any points, because you didn't justify it. Oblique asymptotes. So if we show, the way to find them is x approaches plus or minus infinity. We know that 4 over x plus 2 goes to 0 when we have plus or minus infinity. Therefore, the equation for the oblique asymptote is y equals x minus 3. In both directions. You also need to show that it's both directions, or you lose the point. This one's worth 2 points. Do you guys all know what oblique asymptotes are?
Yes.
Yeah. Yeah. They're not horizontal, but they're at an angle. So the graphs can look like that. If that makes sense. What do you mean? Oh, you need to show. Are you saying whether this counts as justifying or something?
No, you just wrote both directions.
Yeah. And it will be both directions on your exams. Yeah. Like I'm 99% sure it's gonna be that. So this problem actually shouldn't be hard. It's just memorizing what you need to write and just doing it. learning what to run. Finding all right, can you guys calm down a little? Finding all vertical and or horizontal asymptotes, and we have to state the direction. That's testing at x equals 2 or negative 2 from the minus side of y, which is of x minus 3 plus 4 over x plus 2. That's equal to negative infinity, and we sort of already found that in part B when we looked at the dominant term when x approaches negative 2, because this term becomes a negative 5 while this term goes to negative infinity, so that's why it's dominant. Now, if we had a minus sign here, you would need to remember to make it a negative or a positive infinity then. Okay? So it's not just memorizing, it's understanding too and changing the signs if you have a negative or a positive, something like that. X approaches negative 2 from the positive side of y. That's equal to positive infinity. And we have to write, therefore, x equals negative 2 is a vertical asymptote in both directions. Now, if we didn't get infinities, say we got a number, what would it be? It'd be a horizontal. Wouldn't it?
When you plug in x equals infinity, your answer is. And then when
Yeah,
you
that's
go to
true.
leave, you don't get.
Yeah, actually, that's what I said was probably wrong. What Sarah said, which is approaching a positive or negative infinity. Oh yeah, so you know how we have oblique asymptote? That would actually be a horizontal.
There is no.
There is none for this one because we have equation.
We read that as our explanation, like there is an OA, so no region.
That would just be wasting your time.
So we don't have to worry.
No, you don't need to do anything.
Okay.
You saying there's one because there's an equation?
Sort of.
Yeah, because the difference is
Yeah.
we'll cover all spots.
If y was equal to say a 4, that would be a horizontal. But we have x minus 3, which is at a slope. Are you guys good with that problem? Yeah.
It says x minus 2 is
Vertical. Yeah. Are you guys all good with this? Sorry about that. I should not have confused you guys. All right, the last problem. Symmetry is really easy as long as you just remember what to switch out. So, with approaching the y-axis, we need to remember wherever there's an x, we need to change it to a negative x. That's equal to x squared plus 3xy plus y squared. That's not the same as the first equation, so we need to write not same, therefore not symmetric with respect to the y-axis. Are you guys good with that? Pretty simple, just substituting it in. Symmetric to the x-axis. Wherever there's a y, we need to plug in negative y. Therefore, we get x squared plus 3xy plus y squared. That's not the same. Therefore, not. Yep. For each single one, you need to state it. Or, yeah, each of these is worth 1 point, so if you don't state it, you lose all the points. With the origin, we need to substitute a negative x for x and a negative y for y. So it's negative x squared minus 3 times negative x times negative y plus negative y squared. Can we quiet down a little, guys? So we have x squared minus 3xy plus y squared. That is the same. Therefore, it is symmetric with respect to the origin. And the next part, they just tell you to sub in x for y. So we get y squared, or y for x, minus 3 times y times x plus x squared equals 5. Therefore, x squared minus 3xy plus y squared is equal to 5. That turns out to be the same. So it is symmetric with y equal to x. Y equal to negative x. Again, we just sub those in. We again get the same function that we had at the beginning. Therefore, it is symmetric with y equals negative x. So for this part, there's nothing really hard about it. It's just knowing what you need to sub in and making sure your algebra is correct. Do you guys have any questions overall? And the last one? No, it is the same because these y squared and x squared turn out to be positive, and you still have a negative 3 times xy.
Why is that? Why is that though? Why is that negative y? Shouldn't it just be y?
This?
Yeah, no, middle term. Middle term that should end up being plus yx. Because that
Right.
y should just
This term?
one on the left should be negative y, right? So
This term.
in the middle, the y, yeah,
That term. Okay.
y is negative.
X is equal to a negative y.
Which means y is negative.
So if there was an x here, we'd sub in a negative y for it.
Isn't that what you just did?
It's sort of the same with the origin. For the origin, actually,
You put it in negative, you should flip that.
don't you do negatives? Yeah, you make everything a negative. Negative x for y, negative y for x. Yeah.
I went to like a collaborative session, and they said I should try and substitute x for y.
X for y and what? Can you come up here? Yeah. All right. Thanks for coming, guys. Good luck on the exam.
Do you know what the show your work homework is? Like the specific like videos